data networks, and the second film is about topologies. So first of all, what is a topology? According to Merriam-Webster, it's a branch of mathematics that is concerned with those properties of geometric configurations which are unaltered by elastic deformation. So it's basically the layout of things. So here is an example of a trefoil knot where you have the layout of that knot drawn in this figure. And you can also have the topology of a landscape, which will be a map where you see all the valleys and mountaintops and rivers and such. In network topology, it's the physical and logical layout of the elements in that network. And here are examples: ring, mesh, star, and line, and so on, which I will go through in a second. So the physical is an overview of the physical connections and how one element is connected to the other, while the logical topology is how the data flows between elements. So we will come back to an element where they are connected like a star but act like a bus in a later example. The bus topology has its name from a bus line, actually, where you can see you have different bus stops. But what you have in a data network is that you have one line that is common for all the elements in the network, and they connect to the same line. So it's a physical cable here where the computers and network devices connect to this physical line. In order for that to work, you need addressing. So each device here must have a certain address according to rules set by the protocol, but they could be easily named, for example, 01, 02, 03, 04, and so on. So if this computer here wants to send a message to this computer, it has to address it to computer number 4. In that way, computer number 5 and 6 and 3 and 2, they know that they should not study that message. It's not for them, so they can ignore that message. Messages that are not for one of the devices will simply be ignored. In a star topology, you have devices connected to a central unit like this. Maybe this should actually have a different color just to illustrate it, but you have, for example, computers connected to a central device here. And in that way, it's much easier to add new computers, new devices, or as they are called here, nodes in the network, because you simply need a free slot here, a free contact, and just cable it to your new device here, without having to turn off the entire network. So all the 5 computers that are here already, they can maintain their network connection and still communicate while I connect device number 6 here. Obviously it requires more cables, because you can't have, like in the bus topology, one single cable that goes throughout the building. You need, from each and every point, you need one cable. So you can see if you add up the wires here, it will be more than what you have here. So that's the downside, that it requires more cable, but the upside is the flexibility. So that one is actually much more common in local area networks. You also have something called a ring topology, where all the computers are connected together in a ring. That is used for so-called backbone networking. So for example, in the North Sea, we have different platforms. Let's say that we have Troll, Statfjord, Ekofisk, and then maybe Stavanger, Bergen, and Florø. So they are connected in a ring topology like this. The upside of this is that it's reliable. If the connection here is broken, well, all the computers can still reach each other by just going in another direction. But the data is usually sent onto the network via a so-called token passing. That is like having a relay stick, and the only one that can send a message is the one that has a relay stick. So if this computer here wants to send a message to this computer, it will have to send it via the other two here, and I will have to wait until it gets the relay stick and then sends it forward. In that way, you avoid chaos on the network. Other topologies may be fully interconnected, where everyone is connected to everyone else. That basically happens sometimes in a wireless network, but this here, which is the mesh network, is more common in wireless networks, where some can see each other and some cannot. We have already talked about the bus, star, and ring topology. You have a double ring. You have a hybrid, which is a mix of different, which is quite common in local area networks, because you have, for example, wireless in a star configuration and some other network in a bus topology. A linear topology is basically a ring topology that has been broken on one connection. And tree topology is where you have a hierarchy, like the one you see here.